Better we measure, so more accurately we measure, more we can act effectively and prove what really works and what not. So by now we learn that to solve these societal and environmental challenges, one solution is not enough and it will never be enough. So we must tackle the problems from different point of view, from different perspectives, but also with different toolings. So satellite observation, and now more than ever, can be one of these effective tools, but has to be used properly and has to be backed up by in situ, by knowledge, by also local knowledge. That usually is the one that is been always there and often is the wisest voice.
Hello, everyone, and welcome to Problem Solved, a Geoawesome podcast. I'm Muthu, and I'm joined by my guest Federico from Space4Good.
Hello, everyone.
In every episode, we want to highlight real world problems and explore how geospatial data and technology are solving them, ending with the problem solved. So, if you're curious about the real world impact of geospatial, you've come to the right place. Today, we are looking at one of the challenges behind the European Green Deal. How do you measure environmental progress at scale? The EU wants to restore ecosystems, boost biodiversity, grow carbon farming across millions of hectares. But when you think about it, this is a project of a massive scale, and traditional monitoring methods are slow, manual, and are simply not built for this level of ambition. So, if we are to move from policy to real impact, we need scalable, geo enabled systems that provide trustworthy, repeatable data. To help us unpack how this is becoming possible, we are joined by Federico, who's working at the middle of several EU projects that are focused on all of the things that I just mentioned. So, Federico, thanks for joining the podcast. Why don't you start by introducing yourself and your company, Space4Good?
Thank you so much, Muthu. Thank you, Geoawesome, also for the invitation. Personal small introduction. I have background in environmental science, master's then from Wageningen University in the Netherlands in GIS remote sensing. And I joined Space4Good almost 6 years ago as a first intern. Working at Space4Good means since the beginning that I had to wear different hats and covering dynamically different roles. So at the beginning, I was more involved in the data analyst part from different projects, from deforestation to toilet detection, leveraging Earth observation data and techniques. Involved also in the UX and UI part, in the service design realm when we create geospatial platforms, and then transitioning towards more project development and business acquisition. So now when I'm covering now indeed the role of project director, so coordinating the project side of the company, because we also building quite some products, and making sure to maximize this positive impact that we want to have, and trying to move from standalone type of project to possible services. So overall, I enjoy the creation of create something new. So taking, talking to clients, taking the possibility to understand their problems and how we could potentially help them with the Earth observation and remote sensing, but also display to them and be clear and honest about the limitations of that. Space4Good, it's indeed enterprise, social enterprise based in the Netherlands, and it's in our name and our goal. So unlock social and environmental impact and good using and leveraging remote sensing.
It's not very often that we come across names that are just as awesome as Geoawesome. So Space4Good, and I've been following you guys for many years now, is a fantastic name. So you should be very, very proud of that. So let's start with the challenge, right? The EU policy, whether that's the Common Agricultural Policy or whether that's carbon farming initiatives, these all require consistent and reliable monitoring across huge areas. And you already mentioned that one of the key marks of Space for Good is helping customers identify opportunities with observation while at the same time being clear about the limitations. So, from your perspective, when you focus on these policies, what do you think makes it so difficult to measure environmental change at this scale?
Yeah, it's a good question. If we want to look, for example, at the biodiversity measurement, the main challenge is definitely the complexity of measuring such a thing. Thinking about flora, fauna, fungi, and how all these actors come into play, but also realizing how hard it is to understand different species and different ecosystem, natural ecosystem. In fact, with Earth observation, often we are able to, let's say, extrapolate more proxies or a set of proxies to create indicators more than actually do some direct measurement. So we can definitely support with indirect and scalable insights, but the key is also to validate those insights with the in situ measurement. Similarly to the biodiversity, also the carbon farming presents a key pain points in the verification and the precision of the Earth observation-based methods. And additional to that, because carbon credits market is more advanced, let's say, than maybe some regulation that are related to biodiversity, understanding how the stakeholder can communicate efficiently and contribute to the solution is also really important. So we're talking about verification entities, project developers that actually plant something on the soil, but also technology providers such as us. So, in general, of course, we strongly believe in the power of Earth observation data and techniques, being able to, replicate, transfer approaches, and cover large areas. But also, we are aware of the limitation, as you said, and possibly, if we can, we go for project with a strong in situ validation component.
Mhm.
So to leverage, potential global data and models, but they are a bit more shaped and sharpened by local know-how. Um, Maybe good to close with also with that we believe that to build something that is trustworthy and to create and build trust in these solutions, we need to have that approach as an approach that these Earth observation technologies has to be complementary also to other sources or other tools. So to work in a more honest way also, instead of just focusing on the shiny sides, right? Because it's really appealing to say we use AI, we use Earth observation, but also we have to dissect what is the complexity and to think this as a little part of the big puzzle.
I like how you are very open and transparent about the fact that Earth observation is a tool, but you need to use it together with in situ measurements. You need to make sure that the results that you get are verified and cross verified with local knowledge. And given the fact that you're a Dutch company, you remind me of another Dutch company, Satelligence, which I think has a very similar approach to looking at these details. We've spoken about the problem of the EU Green Deal and how the role of Earth observation to a certain extent. Let's maybe move a bit more towards the solutions because I'm given to understand that you are the project manager on a couple of different EU projects, so I don't even know how that you manage it. So let's start with the first one, biomonitor for CAP, so Common Agriculture Policy, where you are designing a system that's supposed to be both scientifically rigorous and at the same time cost effective. Tell us more about that.
Yeah, to be fair, I'm not the project manager of this specific project. This is my colleague Luis, which I touch base upon also before this podcast because I want to hear also his point of view. And essentially, yeah, indeed, we are designing a system with these characteristics that, and do so, we have to first test out all the possible outcomes. What it means with that is that we want to test out all the solutions first. So like going from eDNA to audio, camera traps, and also Earth observation, before actually proposing an actual solution. So that's why also in the context of Biomonitor for CAP, which is this, indeed, as you well said, European-funded project that we are active in, we work together with other institutions. This is essential, the collaboration that we have to have with these other companies to provide this extra data that are coming often from in situ. And then we also have to see how these different solutions talk to each other. So before recommending something to European Commission or to CAP, we need to test out all these new technologies and compare also them to traditional methodologies, how biodiversity would have done, would have been measured before recommending something of value. So not only looking at what is the best, but also which one is the easiest to understand, to digest, to operate, and also which is the most, of course, cost-effective option, right? Because we have to always balance these components.
Okay, so that's an interesting thing, and thanks for correcting me. The fact that Luis is the project manager and not selling you as the project manager for several projects. The other project that you were involved in, and I guess this time you are the project manager, is for CFIs, which is more focused on the nature-based business models and improving transparency in the carbon farming sector. One of the central components when it comes to carbon farm technology is that automatically, it relies on Earth observation. How does satellite data support the measurement of carbon footprints? And I know that there are a lot of carbon credit agencies and that carbon credit systems are quite well established. But how does Earth observation play a role in the credibility of these credits and the adoption of carbon credit certificates?
Yeah, no, indeed. For this time, I am the project manager of this project. It's actually a I3 instrument funded by the European Commission, one of the first ones also of this sort, because it's a new structure that was started after the Horizon 2020. And indeed, within the consortium, which is a really large consortium of institutions, research institutes, but also other data providers, different type of technologies too. Imagine that we are talking about fungi remediation, phytoremediation, to desalination systems for agroforestry systems, and also blockchain. So it's really a big pot of different technologies that now coming together to support the carbon credit system. Definitely, in all these satellite data can make this measurement more, say, objective and consistent, but also using some of the properties that Earth observation has, for example, going back in time for what we can. This help to track biomass changes, maybe also long in time, more than just focusing and looking what is the situation now. Because imagine that we're planting trees now. So I think the first batch of trees were planted 2 years ago. And for every of these technologies, still the trees are way too small to be counted. Biomass can, but we can, with satellite observation, for example, looking at the trends of the same species in the same region, looking at the plots that are just next to the plantation ones. So these plots became also part of the research to model what's going to happen in the same region with the same species in time, and to what to expect in a certain extent. In the context of InnoForCFI, we were also working not only at different stages of biomass acquisition, because everything boils down to that, even if we measure a lot more, let's say, ecosystem variables, um, with starting from different levels of acquisition. So looking at in situ with the forest experts, looking at in situ with optimized applications, so really with the phone, taking a picture that estimates the biomass, with the drones, and then we come also on top with satellites. But also, we're going deeper within the in situ realm, because we're working with institutions like CNR in Italy that are able to measure biomass also in a disruptive way. So basically, uproot the tree, dry it, and weight it. And this type of approach, even if it's disruptive, is done to really to create allometric equation that can be, more precise for those specific species and also ecoregion. So model something that is really not out of, let's say, a scientific paper research, maybe for another area, but is really specific to those specific trees and ecoregions. And of course, this is possible also in the context of the project because it's a research center, research plots. We call it living hubs. And we know that this is not always possible. It's not always the case because you cannot ask farmers to uproot trees. But
You can try.
we can try. But I think this is really interesting to see how this European funded project can help us to do a lot of research and development of, transferable knowledge, especially in Europe.
I find it very interesting the fact that there is this destructive element where you have to take a tree out, weigh it, and find out how much carbon it stores, and at the same time you can use Earth observation and old imagery to gain an understanding of, well, the tree in 2 years' time has grown so much, so if it grows according to the trajectory we've seen in that area, then it's potentially going to weigh a ton, and we know exactly how much of carbon that is because we have actually weighed a tree. So it's a very scientific process, and at the same time, it has a very clear business case behind it because you're not doing it out of just scientific reasons, but it's all about making the carbon transfer, carbon credit system much more trustworthy. So it's a nice example of where science and business come together for a positive benefit. Yeah.
Yeah, a really good contamination in this sort because often we have, let's say, our own path to follow, and in this case, when these streets, meet, I think you can really actually take the good of both worlds, the research, but also the applications or businesses that needs to, sell, create something that is trustworthy to sell a product, but having the backup of an institution that has as a main goal prove that that approach is scientifically valid. I think it's a super interesting point.
Yeah, I mean, we all talk about interdisciplinary teams or cross-disciplinary teams. So this project seems to be a very good example of why that's needed, because no one sector, whether that's Earth observation or biodiversity or finance, could have solved this problem if we don't work together. So that's great. So we've spoken about the challenge around the Green Deal. We've spoken a little bit about what Space for Good does with these two projects. I think we now need to shift to two things that I'm always interested in. One, what are the engineering challenges that you face and how do you go about solving them? Because when we talk about the Earth observation sector, there is a lot of value in learning from each other's engineering challenges and benefiting from that, because ultimately the faster we are in developing our products, the more customers that we can serve.
Yeah, thanks for the question. I think I would, split the problems in the main two problems into two. One being machinery. We know now, how important it is to use AI-based models, but this comes to a cost. Comes with computer machinery, GPUs, all the resources that you need to provide. And that problem is not only related to the money that you need to invest in this machinery, but also how, let's say, green is this, how sustainable is this, if you know that you have to run such a big machinery for such a model. So, for example, one, let's say, approach that we have generally is to start from uh, easier models. Like it's always AI based model, but instead of maybe using deep learning, we use machine learning models because maybe this will not request all this computing
Mhm.
power. Of course, if that is a task that anyway a machine learning based model can perform. The other problem and challenge, I guess, is related to the resolution of the data. A lot of data now available, but and when I talk about resolution, I'm obviously talking not only about the spatial resolution, but also the spectral and the temporal resolution. We work at different applications, and this means that different features that we want to measure or monitor require different type of resolution. So European projects like the European Space Agency, Copernicus, definitely are the type of data that we rely on heavily, but sometimes they are not enough. So in the case of a fire detection, for example, we need high temporal resolution. Or in the case of biomass assessment for small plots in Europe, as is the case of for CFI, high spatial resolution are needed. So this is when, for example, we made connection with the data providers or a platform like Up42, where we can search for the best commercial satellite imagery and also test which one is the most appropriate for our use case. And I think it's key there to see how, indeed, often also different data providers can deliver, let's say, spatially the same resolution, but we have to always apply somehow with testing
Right.
data. So having this chance to, first of all, acquire high resolution imagery, and in this case, thanks to also the European Commission for funding this as a part of the project,
Mm-hmm.
um, let us not only test the best approach and the best data to use, but also considering at the end of the day to deliver a solution or a product or whatever application that is maybe that we need to think with in different stages of resolution. We have, for example, for biomass, developed models or pipelines that are fully open source and other ones that are fully based on commercial satellites and Situ application. Because at the end, when we have to apply this real application to a real world, most likely clients will not have maybe the money or the budget to pay for higher resolution imagery. So we can rely maybe on our more open source type of data. But for other application, maybe clients will be happy to invest some money for high quality data. So we have to always balance these things up. But this different resolution allowed us also to build different things that serve the same cause. And again, be honest about what are the possibilities and limitation of that, because of course one would expect that with the high resolution imagery, you would always perform best outputs. But I can tell you this is not always the case. We proved, and we also been doing some research, scientific research, about the fact that often, for example, for sparse trees, high resolution imagery are a game changer. But when we are talking about forests, for example, crop, then European Space Agency Copernicus programs help us already enough and doesn't change much the preciseness of the output. So it's not worth it to invest in high resolution imagery.
Yeah, it's good that you actually tested it out rather than just relying on conventional wisdom. So that's great, and I'm looking forward to reading that research paper or article very soon. One of the main things that we like to do at Problem Solved is to make all of the things that we're discussing more concrete. We like to call it the problem solved movement. So basically a situation in which an end customer, whether that's a farmer, a land manager, or a policymaker, was able to act on geospatial insight in a way that wasn't possible before or wasn't easy before. So what would be the problem solved movement from your experience working at Space4Good?
Yeah, thanks for the question. I think I would have a lot of these examples.
I'm
And
glad to
also,
hear that. Yeah.
also we're working towards, let's say, measurement of this impact, because often we have, as I guess everyone, this sort of evaluation by the end of the project where we look at what worked, what didn't, let's say more the satisfaction level of the client, but then we're working towards more going back to those clients in 6 months, a year, and to ask, okay, how did you use the insights that we provided? And that's, I think, is the real, impact measurement more than 5 stars just at the end of the project. So I would rather listen to them how and if those insights were useful. But if I have to choose one, also because um, it's one of the first exercises that we have at Space4Good. We started our journey with the conservation project in East Kalimantan in Indonesia. Imagine 200,000 hectares of forest that are where and are still affected by illegal encroachment, so deforestation and fires. And we support the organization managing the land of this super valuable ecosystem from indeed deforestation, fires, mapping biomass, mapping vegetation indexes, to even create navigation systems to go through the area from place one to B, because indeed once we would launch the alerts or these near real-time alerts, then the managers had to respond efficiently to the alerts. But it's not an easy environment, so you have to find your way in, because it's indeed might be that the bridge is down, it might be there is a flood, might be that the forest is too dense that you can't really assess the damage. So seeing the result of this Earth observation based monitoring that we had throughout these years and receiving direct feedback has been, one of the greatest things for sure. And nowadays, if we quantify also this, I think that we have numbers that show these results and this impact, reducing, for example, helping reducing deforestation by 60%, and doing so also with less patrolling efforts. So this then has a result on using less fuel, for example, and also then to be more carbon neutral, even in the process of MRVs. So this is one of these examples that I found really interesting also because we built it throughout these years, this direct connection with the organization in Situ, and these applications also help us also to shape other type of applications. So I think it's interesting for this.
It's a fascinating example, and I love the fact that you were able to quantify it and say 60% less patrols than before. Even deforestation um, monitoring can be a carbon intensive activity. So it's great that you were able to reduce it by a significant percent. I think we could potentially be talking about this for the next hour, but I know for the sake of the audience and your time as well, looking ahead, when you think of the future, what is the single most important message you would like to leave the audience about the role of geospatial technology in future proofing our critical environmental goals, whether that's the EU space deal, whether that's nature-based financial markets? How do you think geospatial can play a role in having a sustainable future?
Yeah, I think, indeed, despite how we measure things, but better we measure, so more accurately we measure, more we can act effectively and prove what really works and what not. So by now we learn that to solve these societal and environmental challenges, one solution is not enough and it will never be enough. So we must tackle the problems from different point of view, from different perspectives, but also with different toolings. So satellite observation, and now more than ever, can be one of these effective tools, but has to be used properly and used has to be backed up by in situ, by knowledge, by also local knowledge. That usually is the one that is been always there and often is the wisest
Also
voice.
overlooked.
Yeah. Often it is, yeah. We have often this approach to, almost to impose technology because we strongly believe that that's, the way to move forward, the way to do innovation, to take something that maybe works somewhere else, and then we have to export, copy and paste in other areas, assuming that will work. But that technology, I believe, doesn't work if it's not, well received, if it's not digested according to to local know-how, and if it's not leveraged, because ultimately it's going to be the people that will use that technology there that will make the change. Often we say, we are for good, but we can make that good only with the people that have their boots on the ground. So that's something that we shouldn't forget.
Federico, this has been a fantastic episode, and I'm pretty sure I'm going to be referencing this with a lot of people. Thank you so much for taking the time, and
Thank
thanks to
you.
our listeners. Don't forget to follow Geoawesome for more insights and Space4Good. See you next time on Problem Solved. Thanks, everyone.
Thank you. Bye bye.